Yeah, I have to split it.
I think it's
I'm like the gas in the lab. Oh, right. Good, good. Oh, wonderful. Yeah, I was not much of a
There's a bunch of high schools. Thousands. Yeah, that's just, there's German guys that every time
And I'll say.
All right, I think we are ready to rock. Is this being live streamed? If not, okay. You guys hear us okay if we don't use the mics? I feel like, is that okay?
Yeah.
Okay by you too?
Yeah, of course.
Generally a loud person, so you don't need to hear me amplified. So Dan O'Keefe, I serve as Commissioner of Economic Development and Chief Innovation Officer for the state. I'm extremely excited about this conversation. For those that don't know RTX, although I suspect if you're here you do, it is one of our iconic companies. Made of a number of brands. I'll let Michael introduce himself and the company in a bit more detail, but of course Pratt and Collins here in Connecticut. So excited about the conversation. Do you want to introduce yourself? Just give some background.
Sure. So Michael Winter, I'm actually a Yale graduate from PhD 1988, a long, long time ago. Been with Legacy UTC for 38 years, right out of, came in as a fresh lab rat PhD in United Technologies Corporation, which merged with Raytheon in 2020 to form RTX. RTX is the largest aerospace defense company in the world. It's Collins Aerospace, Pratt & Whitney, and Raytheon. Last year we had about $88 billion in sales. We have 180,000 employees. An interesting data point that 60,000 of our employees are engineers. That's 1 in 3. And we spend something on the order of $7.5 billion on research, technology, engineering, and product development. That's our money and our customers' money. We're significantly based here in the state of Connecticut. We have 16,000 employees in the state of Connecticut. We also spend annually something like $2.3 billion in Connecticut on the supply base. So a little bit about me. Let's see. So my role currently is the chief scientist for RTX. So I play a key role in ensuring the integrity of our technology portfolio. We have a very broad technology portfolio with 10 key roadmaps that span across all of the divisions. We spend something on the order of $3 billion on technologies that are less than technology readiness level 6, which is the NASA DoD metric for sort of technologies that are not yet mature. Very significant. So that's number one, is to ensure the integrity. Number two is to focus on technologies that span our divisions. So one of the things I've been focused on as an example is hybrid electric aircraft. Take Pratt & Whitney propulsion systems, take Collins aircraft electrical systems, where we're significantly positioned, combine them to make hybrid electric airplanes. Also things like putting Pratt & Whitney propulsion systems onto Raytheon cruise missiles is another example. Tomahawks are in the news a lot these days. You can read about that. So that's the second part of my job. And the third part is to represent that technology portfolio externally. So I do a fair bit of this, and happy to be here at this event.
Awesome, thank you. And I see there's some younger folks in the room, so maybe talk about your career path. How does somebody go from Yale, a safety school, to, just kidding. Just kidding. How does someone go from Yale to ultimately becoming the chief scientist of a global corporation?
So I'll go way back.
Yes.
I flunked out of junior high, full disclosure.
Seriously?
I got
flunked out of junior
here
high.
in New. I got 5 Fs on the report card. I still have the report card. And my parents weren't even going to send me to high school. I was going to become a automotive mechanic. I went away to a Jewish parochial school in Rhode Island, Ended up going to engineering school at Drexel. Drexel was a co-op program, which is 5 years, and you work 6 months out of the middle 3 years. And my first internship was at Israel Aircraft. They said, as long as you get a good engineering job, you go wherever you want. So I was like, okay, I'll go over there. So my first job in the aerospace industry doing design work on airplanes was in 1980, 46 years ago. And that's where I got bitten by the aerospace bug, and I've been kind of doing aerospace ever since. Undergraduate in mechanical engineering, did a lot of the rest of my co-ops at the Franklin Institute Research Lab, and I really liked the idea of doing research. Ended up going to get a PhD, and the professor that I liked the best was here at Yale. So I ended up coming back to New Haven and did 2 masters and a PhD in just under 4 years. And then turns out that at United Technologies Research Center was the only executive who had written the only book, textbook in the field that my doctorate was in. And he hired me. I met him giving a guest lecture in a graduate quantum electronics course here at Yale. And he ended up hiring me after I graduated. Grew through the technology ranks in the research center, spent 14 years there. I led advanced technology at one point when we spun out our fuel cell division, UT Power. I led advanced technology for about 5 years for Sikorsky aircraft and for what was Hamilton Sundstrand, now Collins Aerospace. And then in 2002 went to Pratt, spent 13 years at Pratt, leading systems engineering and then later leading technologies. I had the opportunity and privilege and pain of maturing all the technologies that went into our geared turbofan engine, which is...
Hence the pin, for those that can't see it.
The geared turbofan engine was a new engine that's 20% more efficient than anything that was flying previously. It entered service in 2015. And the technologies that went into the F-135 engine for the F-35 Joint Strike Fighter, which is together with us and 21 other countries are flying today. And then I went to corporate for a couple of years to lead systems and control engineering, back to Pratt for another 8 years, and coming up on 2 years as the chief science officer.
How old are you?
You failed middle school at
I'm
2
up
years
to
old.
94.
I look younger than I am.
By the way, show of hands, who in here failed middle school? If you did, there's still hope. You got a chance. Looks like you're at the end of one.
Trying to give my life story.
No, I think it's really helpful for everybody here. The context on the company, context on your background. By the way, hopefully everybody knows, Connecticut has just an incredibly long and storied history in the aerospace sector. We now like to say you can't fly without Connecticut. 25% of every aircraft part in the country, or every flight is built here in Connecticut. So very long history in the sector. And let's talk about that. Let's start at a high level. Let's talk macro. When you think about kind of global megatrends driving the aerospace industry, and use the context of your whole longitudinal lens observing it, what's driving it now? What do you think is going to drive it in the future?
So I like to think in terms of the big crayons. Let's go back to sort of 2020 was a sort of a pivotal year. It was about 19 megacities. Those are cities that have 10 million people or more. And so it was the first time since 2020 to 2025, we've seen a shift that of the 8.3 billion people on the face of the planet, about half now live in cities. And what that means, cities are more energy efficient, right? If you stack people up, they less heat loss. Husbandry is fairly energy intensive. So number one, it's more energy efficient, and that obviously has important implications for us today here on Earth. Number two, it's economically more efficient. Right? We all learned about the money multiplier. Every time a dollar changes hands, there is a multiplier effect in the economy. And of course, we've sort of seen a proliferation of that now with online trading and AI agents and so on and so forth. So it's accelerating. So in 2025, we went to somewhere between 32 to 42 megacities. And so what happens? You have the rise of the middle class. Can anybody shout out what percentage of the people on Earth have ever set foot on an airplane? Anyone want to guess?
22.
It's pretty close. It's about 1 in 5. It's just under 20%. Ever. Not like people like us who get on a couple times a week, right? And so all those people are going to get disposable income and they're going to fly to go see their relatives and friends in other mega cities. And so that's a rise of people starting to travel. Now, we did have a suppression of demand through the COVID years, but that was pent-up demand. And now we've seen an explosion of really people wanting to travel. And so the aerospace industry is, for the first time in history, and this is true of really the aerospace and defense industry, because, oh, by the way, in the last 5 years, the world got a lot more dangerous, right? We've had the rise of near-peer adversaries. So that's the second mega trend, is really the reintroduction of near-peer adversaries for the United States of America. And so,
How do you define near peer? I think I kind of sense, but maybe China is probably the principal one you're thinking about.
So the Department of War does have some more refined metrics, but it comes down to things like, can they defend their airspace, right? Because access denial of the airspace is a key parameter for a peer adversary, as an example. There are also metrics associated with percentage of GDP being spent on defense, and that's why the current administration is so focused on that with our NATO partners specifically.
Got it.
Okay? Good, thank you for asking. So, the rise is, so the manufacturing base, so if you go to buy an airplane now, you don't take delivery for 10 years. So there's this huge pent-up demand because it's the same manufacturing base for these aerospace defense systems as well as for commercial applications. For the first time since World War II, we've actually shifted from a demand-constrained environment to a supply-constrained environment. There's not enough manufacturing base on the face of the planet to satisfy the demand. So that's really the third mega trend that I'll highlight, is that there's this huge rise of manufacturing. And so the combination of that, and just to cite some data here, in the next 20 years, there's a demand for about 44,000 airplanes. There's 30,000 commercial airplanes in the fleet today. We're going to replace half of them, and we're going to double that. So that's about $6 trillion worth of sales, another $1.5 trillion or so in engines. These are kind of big numbers, right? And so that's going to drive demand. It's not just true there, it's true across the board. And so when we talk about the technologies, there are some enabling technologies that will facilitate how do we satisfy this demand. The last thing I'll say is localization. And that's becoming probably the fourth mega trend. We see it in Europe and in the United States, really, both for economic reasons, the focus on reintroducing manufacturing jobs here in the United States. Europe is refocusing on their defense procurement to be on the continent. And so a lot of that localization. But there's another factor to it, too, if just looking at the scale. If you're producing 75 commercial airplanes a year at the Boeing company or at Airbus, you need to make things close in. Another example, in March, I saw recently in an article, they shot down 33,000 Russian projectiles, 33,000. So they used air effects to shoot down, so that's 66,000 flying machines. Just shipping them, if they were produced here in the United States, shipping them across the ocean, that logistic chain is not sustainable.
So so that's sort of the more macro, super helpful to understand those trends. Now bring it down, enough about you, now about us, meaning Connecticut. Let's talk about a little bit more locally. When you think about those local supply chains, and by the way, for the audience, many of you hopefully know, manufacturing is one of our largest industries. Our second largest industry, it's about 12% of our economy. Kirti Patel, our Chief Manufacturing Officer, represents it for the state. But that is actually down from its peak. At one point, it was 17% of our economy. It's down now to 12%. But it's growing again. It dropped from 17 to 10, now back up to 12. Some of that was non-durable goods, chemical companies, things like that, leaving the Northeast. But a lot of it was also the dismantling that happened post 9/11 buildup. And now we're starting to see it increase again. So when you think about those supply chains, for us, we have these 3 large national defense primes, but it's all the supply chains underneath them. How can we build more capacity to make sure that localization, those more local trends, the supply is ultimately delivered?
Yeah, so let me reflect on that first from the local basis. The last time, most of our jet engines, we make them in a number of locations around the world, but most of them are made right here in Connecticut, in Middletown. The last time we made 1,000 large engines in 1 year was 1983. And we introduced the combination of the F-135 for the F-35 Joint Strike Fighter. There are over 1,000 of those airplanes flying today. We also introduced in the same time frame our geared turbofan. This was, as I mentioned, the engine was about 16 to 20% more efficient than anything flying before. It's on 3 different commercial airplanes today. We've already sold thousands. We actually delivered over several thousand of them. We've accrued 50 million flight hours. 16% fuel efficiency translates to something on the order of 3,500 tons of CO2 per airplane per year. So it's a fairly significant number. Put that in perspective, if you think in terms of trees, a tree in the forest, the sun is shining, that's equivalent of 950,000 trees per airplane per year, equivalent respiration. So those are significant impacts. That's also economics. 30% of the cost of running an airline is fuel. And so in 2017, we broke that 1,000 again. In 2015, we were 500 engines. In 2 years later, we broke 1,000, and we far surpassed that today. Those are engines that are being manufactured here in Connecticut. The supply base, much of it is local. As I mentioned, we spend $2.3 billion a year just here in Connecticut, but we're also in the surrounding regions, the southern New England regions, combined with Collins Aerospace, where we have major facilities here. You've probably seen right across from Bradley Airport, and in areas like even in Rhode Island, Portsmouth, Rhode Island, we do a lot of our naval systems, making torpedoes and radars and things like that. And of course, we make missiles and effectors and radar systems in the Massachusetts area. So really the whole New England base is our core for manufacturing, and the local supply chain is absolutely critical to us.
Got it. Very helpful. And you mentioned some of these sort of trends into the future, some of these innovations that are happening. Let's shift gears and talk about that a little bit, some of the trends that are driving the future. I grew up on the Jetsons, and they freaking lied to me. Where are my flying cars? We got a robot up front, so we're getting closer on that wheeled robot in the Jetsons, but we still don't have flying cars. When is that going to arrive?
So we actually do have flying cars in other parts of the world. We have a highly litigious society here in the United States, but we're getting there. What are, again, sort of starting with the mega trends, number one is ubiquitous data. We have data are available everywhere. And remember I mentioned that the manufacturing bottlenecks and those constraints, there's a liberation that'll happen with Factory 4.0. And so all of the new factories we're putting in place and converting our factories to be focused on that data. Number two is unlimited connectivity. Unlimited connectivity. And, you know, we all use Wi-Fi and 5G and all that good stuff. That's kind of old school today. But think about what's happening in terms of the proliferation of satellites. In the year 2000, at the millennium, there were something on the order of 990 active satellites. In the year 2024, I'm sorry, there were 990 active satellites, so call it 1,000. In 2024, we hit a milestone, 10,000 satellites on orbit. 2 years later, we just hit another milestone, 15,000 satellites on orbit, and that number is forecast to be 100,000 satellites for connectivity on orbit by 2030. And so we'll all have, you know, if Starlink or some equivalent connected to our watches, to our phones, to our factories. And so that ubiquitous data connectivity combined is going to liberate our ability to do things. We've already started to see that. In one of the panels yesterday, someone was talking about Uber, of what the innovation was, and they talked about, the smartphone and geolocation. I think it's actually more about, it's a business innovation. It was the opportunity to unleash unutilized capital, right? It's the business innovations that we will use to take advantage of this. Then you enter AI. AI is already becoming in use across every phase of the life cycle of our digital thread, from the conception of the engines and the using the genetic algorithms to understand where are the optimal solutions, all the way through the aftermarket and maintenance, repair, and keeping the fleet flying. And so that's going to happen in all segments across the board. There was some conversations about using AI. You asked how old I was. I remember in the 80s, people were talking about, will your business use computers? Right? It's like, will you use wrenches in your factory? We're all going to use it. It's just a question of what we use it for. And then quantum. And that sort of turns the corner today, and I've been thinking about quantum computing a fair bit lately. Quantum in particular, we have to think a little bit differently about what are the fundamentals of the base computer structures, right? There are 7 known digital logic gates. There are 6 fundamental building blocks in a digital computer today. What are those analogs in quantum? And they're not the same. They're not at all the same. And so we have to redefine our basis set to harness that. And I think really excited about the Quantum CT initiative, which is a public-private partnership. Hopefully the state will win an award. It's a partnership between the state, UConn, and Yale, and a number of companies, including RTX, are on that. And hopefully that, with that financial backing, we'll be able to unleash quantum for the state of Connecticut.
And what about infrastructure broadly defined? So going back for a moment to autonomy physical, right? Because I think of autonomy as being physical or virtual. Physical is subsurface, surface, and flight. The virtual, more AI-driven decision making. Focusing on the physical for a moment. Is there infrastructure required? So eVTOLs, which are these electric vertical takeoff and landing devices, the flying cars that Jetson promised us. What's putting the litigious nature of our society aside for a moment, what's some of the infrastructure you think we need to build out to make sure that the physical side of autonomous can thrive here?
So first, good news, the FAA has passed the legislation and put in place through the public rulemaking process the ability to introduce these vehicles into the national airspace. So that's a really big step. Up until recently, I was sitting on the NASA Advisory Council because I think it's not just conveying people, it's also conveying material. So much of what we do is delivering packages and delivering material. Interesting data point, if you look at the movement of material, that's another kind of $6 trillion a year business globally is moving things. It turns out 0.5% moves by air, but 35% of the by mass and volume, but 35% of the value moves by air today. And so that last mile solution with drones. So as part of the NASA Advisory Council, we did some work together, NASA and the FAA, to introduce drones into the airspace for food delivery. And North Texas was the first public site in the United States, and we went down there for some of the side-by-side trials. I actually have video of me going behind Walmart and ordering a drink, and a minute and a half later it was delivered by drone into my hands, lowered down on a little pulley. And that's coming from in Connecticut as well. And so really excited that that's going to start to happen. So it's a combination of not just the carrying people, but also carrying material that will solve that last mile solution, if you will.
Material is such a fancy way to pronounce that.
Stuff.
Makes it sound so cool.
Stuff.
The French version of material.
Deliver coffee to your bedroom window in the morning. People were literally doing that I've been doing that for 2 years now in North Texas, and are starting to do that in Florida.
And so you think the infrastructure is largely in place, or there's going to be a significant build out to get there? How far away are we for this to be truly ubiquitous?
So you have to sort of follow the thread. There will be charging stations for the drones as well as for these urban air mobility vehicles. And we are investing in this, by the way, at RTX. We actually have what we call a copper bird. It's called Scalable Turboelectric Propulsion Technology, or STEP-Tech. And so we've got the motors, the drives, the generators, distribution systems we make at Collins Aerospace. We have the gas generator engines that we make at Pratt & Whitney. And then we've connected this to propulsors distributed in a wind tunnel in East Hartford, Connecticut, all to a great big battery box we call the juice box. And we're actually sort of flying the missions today. And we're working with a number of these companies, these startups that are starting to develop these. So Connecticut will feature prominently as this happens, and the region will feature prominently as this happens as well. But then you have to follow through. Where's the charging infrastructure? Right? Because it's a huge demand for electricity. If you were to take the commercial fleet of airplanes, burn something on the order of 100 billion gallons of fuel. The United States, 26 billion gallons of fuel last year. That represents about a 15% increment on the world's electric grid. And you want to do that in a way, hopefully, that's environmentally sustainable, right, as you grow that grid. And so those are some of the opportunities that are before us as well. So you sort of have to follow the thread. Where's the infrastructure that stands behind it? And the charging infrastructure and the electrical grid infrastructure and the generating capacity, even the transmission capacity, all that has to catch up.
Yeah.
And that's going to be a huge investment.
Yeah. By the way, I won't hijack this conversation about energy. That's a totally different topic. But as you hear about these debates about what we're going to do about energy in this region, we're part of a regional ISO, so it's all of New England. This is why it's so critically important to add supply. We've seen demand be flat to down over the last decade because of all the efficiency we've brought in. That's the good news. The bad news is forecasted to increase. Things like electrification of the grid, everything Michael just described, but then also AI and the cycles associated with it, and ultimately quantum, which will drive more uses of AI. Our prices in this region are 100% higher than the rest of the United States. There's a whole complicated reason why we're there, but that's why I hammer this topic so completely. It's truly going to fuel our innovative future. What do you think all this means for our economy? Again, if you draw out these threats and you say, here we are 10, 25 years ago, from now, what do you think it means for the economy of Connecticut, for the region, for the country?
The future is bright. And you go back to the history, Connecticut is, back in the 1800s, right, we were known for precision manufacturing.
When you were in middle school?
Yes. My buddy Eli down the block there. The future is bright, and so we were known for precision manufacturing. We were known for things like repeating machines and replaceable parts and metalworking. And so those things, ultimately to make stuff, you still need to make the hard, lumpy objects that represent that infrastructure. And so it's great that we're working on all these apps, but you still have to make things, and those are manufacturing jobs that are going to be really important for the future. And so it will be predicated on attracting the right investments, both privately but also public-private partnerships, also from the federal government. We are very much partnered at RTX with the state of Connecticut, and we really enjoy and appreciate that very much. And then thinking about what are the jobs for the future, right? And so some of the investments that we're making are focused on that. What are the infrastructure for training those people? Some of those to work in our factories to build jet engines, but what are we going to need for the future workers on the quantum computers of the future? I know we can call them quantum mechanics. Sorry.
So actually that brings up a great topic though. What role do you think universities play? We've got folks here from UConn, from our state college system, from Yale. And I'd love to hear your thoughts, not just on the future quantum mechanics that'll be trained, but also folks, let's talk about the trades too. One of the things I often wonder is have we really kind of over-indexed towards this concept of a 4-year liberal arts degree, which by the way, I have one so I can say this. where you lever up to the till, at times to the detriment of some of these jobs and the trades, which, by the way, aren't likely to get disrupted by AI. So perhaps are one of the safest jobs on the planet, can provide a pretty incredible middle-class lifestyle. What do you think the role of universities are in this future?
So,
And I should say education, broader than just universities.
so education, especially in the face of AI, education, and especially in the universities, needs to really focus on helping students to learn how to think. Not how to do things, but how to think about things. And my undergraduate education, I'll share a little vignette here. My undergraduate education was mechanical engineering. I learned a lot about how to do things. And then I came to Yale, and I think part of it was the institution here at Yale. And the courses were very different. They taught me how to think about things. And I'll never forget, on your way home, notice the intersection with the triangle where Whitney Avenue splits to become Temple Street, and one way in the other direction. And that's a known area of traffic bottlenecks. And so I took a graduate digital electronics course, because I needed to know, I was a mechanical engineer, I needed to know how to build circuits. And I thought, great, I'll take this course, I'll learn how to build circuits. I went into the lab, I built the first circuit, I built the second. I was old enough that the second lab, we had a keyboard here and a monitor there. You had to be able to push the key, and 10 seconds later have a letter show up on the screen. We had to build this in chips. And I spent 3 all-nighters in a row, and it just never worked. The final project was that intersection. They had a traffic simulator with little LEDs like yellow, red, green, and it simulated, they would throw traffic jams, and you had to build a circuit that plugged in and your grade was basically the traffic jam, how good the traffic was. And after that bad experience, I learned completely different, I thought differently about it. And I remember the time base, computers think in microseconds and milliseconds. I made the time base for this computer the time it takes for a car to transit the intersection. And I did it in 5 chips. I wired it together, went into the lab, half an hour later, I walked out with an A. And it was not about learning how to do something, it was learning how to think about things. And so as we think about AI, that's a really important example. We need to focus on what are the students, how are they learning to think about the problems that we have today and the problems we'll have to think about tomorrow. At RTX, we're partnered with Yale, we give gifts, charitable gifts to Yale. We have financial commitments to do work at UConn every year. We have 44 master term agreements with different universities. We focus them largely into centers of excellence. We fund research at these universities, and we attract and retain the talent based on the work we're doing with those advisors. And that's really critical, and it sort of completes the circuit. The last thing I'll say is conferences like this, I come here because it's a chance to meet different people who think differently and open up. Right? It's very easy to get stuck in the ways you think and continuously reinvent oneself.
Well done on completes the circuit, by the way. I caught the point. Well executed.
Better than the quantum mechanics.
By the way, we are going to open up for questions in a few minutes. I'm happy to keep going, but if folks want to think about questions you might want to ask Michael, please start to put those together now. 1 minute. By the way, so on the concept of AI in the academic enterprise, I have 2 daughters, 14 and 17, for whom right now AI is cheating. I'm okay with that with my 14-year-old. I think in middle school you still have, if you don't fail, you have to still learn your voice and your judgment and your empathy. But I called the high school principal and I read her the Riot Act. I'm like, my daughter's about to graduate and applying for colleges not knowing how to leverage AI as a tool. And I think one of the things, if we are going to see a dislocation, and I think we will, I don't think it's going to be the robots taking over. That'll happen later. I think what's going to happen is people who know how to leverage these tools to do their job better are going to be the ones that get the jobs originally. Are you seeing that? Are you seeing people coming out of these academic enterprises knowing how to use these tools, or do you have to teach them?
I think it's too early to tell, but I think the critical thing is we need to train our own workforce. All of us need to train and learn ourselves how to harness this. I just did a study on something, and we would have taken a team of researchers to do. And it turns out I went to one of our senior fellows, and he did the whole thing himself with a team of AI agents to simulate, putting this particular, it was a way to use hydrogen on airplanes, essentially could potentially decarbonize like half of the commercial fleet if it works. Very immature technology today. But he did this with a team of AIs, and he did all the quantitative analysis. He would have needed about 5 engineers to do that before. I don't think we're going to see fewer engineers. We're not seeing that today, where we've already started to replace coding. We do a lot. We have somewhere between 50 and 60,000 software engineers, so people who do software, not just engineers, at RTX. And we're using AI tools like Fireside as an example to replace writing the code or to do some of the code verification. But it's conceiving the algorithms, and it's bringing the efficiency to those algorithms. We'll still need the same people, but we'll need to raise the bar on what they're expected to be able to do. And I think that's the key, is the workforce is going to harness this. And just like with computers, we'll not need necessarily fewer people, but we'll need them all to do a lot of higher level work, because they won't be doing the mundane stuff that they used to do in the past. And that's really good. That's actually exciting. And it's an elevation of the level of intellect of our entire workforce across the state and the region and the nation and beyond.
Yeah, part of how I describe it is around mathematics. When most of us went to school, we were taught to memorize mathematics. And then they did the new math. And by the way, when my daughters came to me and said, "Daddy, how do I do this problem?" and I would show her, she'd say, "No, that's not how I learned it. That's wrong." And I had to relearn mathematics. And when I finally did that, because I'm a nerd, I realized, okay, they're actually understanding fundamentals. They're understanding principles of how analytical elements relate to each other. And that's higher level. I think the same thing's going to happen now with AI and the written word. The marginal cost of expertise is going to drive to zero. So when expertise is now free, I think that can be an incredible level setter for our society generally, but people have to understand how to leverage these tools.
Let me just add, I have 2 daughters who are professors at universities. One of them is a professor here at Yale in chemical environmental engineering. And so they see use of AI by the students. One of the universities actually has a policy, and they're required to actually take all the papers and put it through a detector to see if AI was used. And the statistics are astounding how much people are using AI. They're supposed to, by policy, debit the grade if it's used, but that's not this university. But it was interesting also that the one here in chemical environmental engineering gives out problem sets to her students. And she put her problem set into one of the AI agents, and it came back with solutions that were actually very different than the way she would have done the problem.
Yeah.
And so it sort of opened up a different logic pattern, and I think there are ways we can learn from this as well.
That's why I think you have to reimagine the academic enterprise. Like put it through the same algorithm and tell me how many mathematics solutions used a calculator. And that's okay, right? That's not cheating, because we evolved to realize you don't have to use an abacus anymore. We've got tools now that we should leverage. What about the startup ecosystem? Obviously RTX is a massive company, translating between kind of university, higher ed, learning, and then into now commercialization and practice. How do startups engage with RTX? How do you think about supporting the startup ecosystem?
So, as I mentioned earlier, at RTX we have 60,000 engineers. And I know that we have the smartest engineers on the planet, but we don't have all of them. So we need to reach out to startups and partner with them to gain access to others with bright ideas. At RTX, we have a ventures arm. We've, to date, invested in 33 companies. I work very closely with them as providing some of the tech due diligence on some of those partnerships where we make those investments. And they span a very wide space of generally aerospace and defense, but mostly in areas where we're not working ourselves. They're complementary to us. And we kind of look to them to help us in those areas. We also work with other venture funds, and we work very closely with them just to understand and compare. And then even beyond, we also, many countries do have either offset requirements when they buy military systems, which there are a lot buying them from us today, And in places like Europe where they don't use offsets, they use essential security interests, there's still partnerships. And their governments tend to want to focus us into their startup ecosystems as well. And so that's a very rich environment for us to partner and invest.
Got it. All right, let's open it up for questions. I know someone over here jumped in first, so I'll give him the first question.
On the exact same kind of stream as your prior question, I'm an early stage defense tech investor, C2 Series B. We've actually done about 3 or 4 investments with RTX Ventures. Curious about the demand signal from a co-investor perspective or from a startup's perspective. When RTX Ventures makes an investment, how should we as co-investors kind of interpret that? And how do you guys think from where you sit about incorporating those businesses into the portfolio of assets that you oversee?
So in general, we need to go faster in technology development and technology deployment. Just another data point, public information, I said we're $88 billion in sales. The last quarterly earnings, we were $271 billion in backlog. So you asked about the economic future. It's right. We just have to go faster. And part of that going faster is we need to be able to move faster. We're not known for moving fast in a big manufacturing industrial base, defense industrial base. And so the startup ecosystem is a huge opportunity for us. So in terms of demand signal, help us get faster, and we'll thank you for it. I mean, that's the most important thing. We need to learn how we've deployed Agile across all of our new programs, and that's helping. But it has to be in the water, and you guys know how to do that. We don't so much. Certainly not in our engineer base. The people who sit in their cubicles, for as many years as I've been working. So.
33 investments. Where do you think that number should be? That's a little smaller than what I would have thought, just given the size of RTX.
We're fairly discerning. We're a fairly conservative company, and so we're very careful. We do invest, just to put some numbers to it, we invest somewhere between 50, again, public and private, $50 to $75 million a year. In these startups, we tend to focus on the earlier stages, kind of Series A, followed into Series B thus far in the 3.5 years since RTX Ventures was started. So I don't know if that gives you a quantitative answer to what you're looking for, but we've only been at it for a few years.
Yep. Other questions, please?
Dave Kraszewski from Harvard Business Journal, just so you're aware.
Thank you.
I'm just curious as to how robotics has changed the production line and employment on the production line, and what you foresee for the future in that.
It's buying its way in, and it's buying its way in for the most part on the basis of quality, more than anything else. We're deploying robots, for example, in Middletown, Connecticut, on some of the things that really needed a lot of touch labor, and those by turning that into a robotic application, gearbox assembly as an example, is a great way to do that, where you can ensure the quality and you can ensure the same quality sort of 24/7. That's really important to us. It's not so much about the arbitrage. I mean, we have really good people, and they are precious to us. Our workforce is precious to us. We're doing it really where the area where the quality is most important. Another area in some of our radar assembly applications where it's very, very repetitive. If you look at sort of one of those Patriot ground stations, there's thousands of little circuit boards sticking into one of those arrays. And every one of those circuit boards needs to kind of be assembled somehow. And so taking all the touch labor out of that is a huge opportunity just to get that quality. And of course, quality is translatable to capacity and safety. That's right.
And I can tell you we're seeing it at the state level, so separate from RTX, it's the state economy level. If you're having difficulty sleeping tonight, this is all on my website, where we're seeing GDP grow faster than jobs. And people ask me if that's AI, and when you double click into it, it's principally in the manufacturing sector. And so I think it's not quite AI, it's more robotics, automation, kind of what we're seeing in the manufacturing sector generally.
But I'll amplify the point I made before. It's because we're doing more, we're producing more. It's not because we're replacing, one for the other. It's opening up the aperture so that we can produce more, we can satisfy this demand, we can get those systems in the hands of the warfighters, we can use those missile systems to defend freedom all over the world.
Look over here. None of you. All right, please.
So when you're covering history of manufacturing in Connecticut, you use the word precision manufacturing many times. I mean, we know about Waterbury being the Brass City, the old Timex building, all that stuff. You used a kind of vague word about quality when answering the previous question on robotics. Are you getting the same precision that you get out of those very skilled machinists, making turbine blades in East Hartford? Or is that a goal you're trying to approach?
So whatever we put out has to satisfy certain quality metrics, both for commercial, for safety, and to satisfy the FAA and our certification requirements, or to satisfy the government requirements and the Department of War requirements to accept those engines. So everything we put out, it needs to be on an equivalent quality basis.
Of course.
And so to achieve that equivalent quality on a recurring basis, on an ongoing basis, on a 24/7, 365 basis, that's the focus. And then to be able to up the throughput in those factories.
About the
When robots
concept
can do it, the right precision is the 30-year machinist on the floor, and obviously the throughput will go up. I mean, we're just kind of asking, is that the challenging point?
So
and I guess it is.
It's a great question. Let me put it in the context of additive manufacturing.
Yeah.
Right, because that's a different way of making things. I think everybody's familiar with additive manufacturing.
Just say 3D printing.
3D printing, instead of right, you do it layer by layer in metal, right? There are things like parts that are going into both the commercial fleet and the military fleet today that are becoming additive manufactured. In fact, we're starting to additive manufacture some of our smaller cruise missile engines. You can make it all as one part. It actually is best if you make it as 3 parts, printed parts instead of like over 100 parts. What goes out the door has to be equivalent. Right, the form, fit, and function must be the same, and so it cannot leave the shop, it cannot leave the factory unless it's the equivalent quality.
And we just had the first 3D printed part go on a commercial.
That's the hard part of your robotics program.
And that's, getting it right, but until it's right, it won't go anywhere.
And by the way, one thing on advanced manufacturing in Connecticut, sorry, I'm the guy that has to give commercials on Connecticut. Because we have this 100+ year history of manufacturing and innovation in support of our national defense, we have this incredible workforce that knows how to make incredibly complicated things, which is why ASML is here. Show of hands, who knows what photolithography is? Fellow nerds. So photolithography, these are the machines that make semiconductors. So believe it or not, every advanced semiconductor in the world, not hyperbole, they have 100% market share in advanced semiconductor production, is made in Connecticut. It's made on machinery made in Connecticut. It's ASML.
Gerber, I assume.
Please.
So I work as a machinist for one of your main suppliers. I went through the community college system, and one of the things that I see on the floor a lot is bandwidth issues. So there, Pratt & Whitney is asking for more and more parts from us, and there's only so many engineers to get those ESA frozen processes done. There's machine qualification and stuff like that. Do you see AI helping with that compliance side of making sure that the parts are documented correctly, the documentation is correct, the statistical process control is correct? And do you see that enabling smaller suppliers to get into the pipeline to grow the base?
So, great question. It has to be done with, the answer is yes, but it has to be done with eyes open. So, as part of our partnership with the Department of War, we have a number of programs, I think 5 to date, that we've signed as part of the munitions acceleration program. And one of the things, if you look at something like a Patriot before it goes out the door, there's a number of acceptance tests that every part has to go through. The inertial, the gyro navigation systems that we built here in Cheshire, Connecticut, for example, go through a series of acceptance tests. In order to be able to produce more of those, we're partnering with the Department of War to understand what are the ways we can streamline some of those tests, still doing either human verification or statistical process control to ensure that we get equivalent quality, but to be able to do that to up the capacity of what we're able to produce. So the answer is yes in general, but we will not do it blindly.
I'm going to go stage left, see if anybody over here is.
I got one.
Pressure's on.
Dr. Michael?
Please.
Yes, sir.
You can build almost anything, right?
Most things.
Could you build?
We do flying machines.
Could you build Dan an Iron Man suit so he could like fly around?
Yes.
A little quicker.
Glorious.
You would think he already had one.
Yeah, but maybe that's one's made by a competitor. You need to get them one.
Anybody in the center? Please.
Hi, my question is that I study at the university that Dan studied at Brown. So I study at Columbia right now. So according to my knowledge, I feel like my university's AI usage policy is very encouraging, right? So you have the professors openly encourage students to use it. And you would never be punished if you use AI wisely in compliance with our policy. But you are definitely expected to raise the bar. But I was really shocked to learn that AI is not so favored generally. So my question is that how do we bridge the gap? How do we bridge the divide? And what kind of principles should we embrace in academics or in other fields? Thank you.
So I can't speak generally about that. I can say that, policy, and the state of Connecticut has an AI policy. We at RTX have AI policies, and we sort of think of it in two flavors. One is sort of at the enterprise level. We have a AI for everyone, and that's through our sort of software infrastructure within the company. But we also focus on, because we make things like navigation systems, we control, a little data point, we control 2/3 of the air traffic on the planet. So we make navigation systems and cockpit systems and the like. And so we also focus on this for AI and cyber for the products. And so we sort of separate those. And so we do really focus between our enterprise and how we do our work and how we produce the products that we produce, and the integrity associated with the products that we produce. And we focus on both of those, and really it's having an overarching policy, and I think that is actually the key.
Yeah, I would just add, I serve humbly on the boards of 3 higher ed institutions, and as you can imagine, I'm pushing hard to reimagine the academic enterprise in an AI everywhere way. It takes time. What you realize is when you're talking about the academic enterprise, you're talking about tenured faculty, you're talking about curricula that needs to be developed, and you're talking about a background, a space that machine learning and neural networks have been around since the 1950s, but the commercial applications we're seeing now are relatively new and moving incredibly quickly. So I've actually found it difficult to see the academic enterprise adjust in real time when the space itself is moving so quickly. The most successful university I've seen so far is the business school I went to, where they're letting students lead. They're letting students come in and say, how are you using AI in these novel and interesting ways? And then they have a group that teaches the teachers. Whenever they see something that is novel and interesting, et cetera, they roll it out to the teachers. So that's the most dynamic I've seen, but that's 28-plus-year-olds. When you work backwards to younger, more formative years, it's a little bit more challenging. Question over here, please.
I own a manufacturing company in the state of Connecticut. I'm curious to know, when you're with your other senior executives at RTX, and what are you guys discussing? What's keeping you up at night in the manufacturing world?
Satisfying the demand. I mean, whenever we're with our CEO, he'll remind us that we need relentless focus on quality and production. He's under tremendous pressure from both our commercial customers. You can read about us and Airbus, for an example, and they would love to make more airplanes, but all the engine companies are constrained. There's just not enough hydraulic presses to make forgings on the face of the planet to do this. So it's really focusing on how do we get that capacity up. One way to do that is quality, and then the other way is to be able to do things faster, effectively, but never sacrificing on.
And just a question out of ignorance. This is not I come from a technology background, so my question out of ignorance is, if we have these long-dated contracts and we can see the demand, I acknowledge that supply needs to be grown with an eye towards quality. You can't just grow simple volume; it has to also have the quality. But are the investment dollars not there? In other words, why wouldn't we just simply, as a country, as a state, as a company, as supply chain companies, why not invest more aggressively in building out that capacity? Or maybe that's already happened.
So those investments are coming, and we continue to make those investments. As you're aware, we're making investments both here in the state as well as in other locations. We just recently had an announcement in Georgia. We recently built almost $1 billion plant in North Carolina.
Way to rub it in, Michael.
So we are making. We've been deals.
We're also investing aggressively in the state of Connecticut. I'm kidding.
So we are making the investments on the defense side. Half of our business across RTX is on the defense, and half is commercial. On the defense side, it's really been sort of a year-to-year thing. And as we all know, the United States Congress has not done a great job of delivering a budget on October 1st, year over year, for quite a while. We're starting to see, in fact, we just saw announcements yesterday by the department on 7-year contract terms and things like that, production contract terms for some of these missile systems and such. That's really an opportunity to understand where we should be making these investments. But with half of the manufacturing base focused on a year-to-year, administration to administration, what's going to happen. And oh, by the way, we're on continuing resolutions, which means you're operating to last year's budget for more than half the year. It's hard to justify the kind of investments, the CapEx. And so that's where these partnerships do become so critical for us.
Got it. Time for one or two more, Kirby?
Yeah. So material science and new materials is integral to RTX. So could you comment on the pace of innovation in the field of materials that are of interest to RTX?
That's a great question. So today, just a little background. A jet engine it's probably the most sophisticated mass-produced device known to humankind. We put air in, we compress it, and then the air gets to be about hot enough to melt rocks, and then we dump in fuel and we light it on fire. So it gets a lot hotter. By the time you get to the back of the engine, it's hot enough to melt all the metal around it. Don't think about that on your flight home. And so the material systems that we use are sort of really state-of-the-art. Typically, it was taking us a decade or more to introduce new alloy systems, these nickel superalloys. You can't use titanium because titanium burns at this temperature. So we are investing in new material systems, which are non-metallic ceramic matrix composites. And these ceramics, it turns out, from an RTX standpoint, it's wonderful. You can put them in the engine at these hot sections. They go into the brakes and the landing gear of the airplanes that Collins makes, and they go on the outside of the wings on the hypersonic missiles, because the temperature environments are kind of sort of about the same. We're also partnering, one of our startups at RTX Ventures is a company called Radical AI. And what they're doing is they've got a atomic level calculation of these material systems. And then we've got an AI engine in the loop and the optimizer. It then sort of uses the ab initio calculations to predict what the recipe should be. They've got a complete robotics laboratory that makes the samples additively, does the testing through this full robotic laboratory, and then takes the data, feeds it into a data lake that is informing the